Hello, and welcome back to our data structures and algorithm series. In this video, we look into Python lists. In our daily life, we do different kind of lists. For example, the shopping list. When you start your day, you want to do a to-do list and many other kind of lists. So this is not very different from the lists that you do in your daily lives. So what is a list in Python? Just like this picture here on the right, a list is almost like an array. So it will store different items at contiguous memory locations following each other, just like this plate holder here. Now, one unique thing about Python lists, unlike an array, is that it can store different data types. Just like this dish holder here or plate holder can hold different sizes of plates or different types of plates. So that's the unique distinction between lists and arrays. Otherwise, as you'll see, most of the properties are actually the same. So it's actually a variable that can store multiple items. Now, it's not the only kind of variable that can store multiple items. Python has three other built-in data structures. They're actually called data structures, and you're going to look at them in the next slide. So they can hold, a list can hold different types of data elements, and it stores this particular data in contiguous memory locations. So data elements accessed using an index number, just like an array. Now, these elements are actually ordered. They are also changeable, meaning after you declare the list, you can be able to change the value in it, and they allow duplicate values. So a list can have values that are similar. Now, the other data structures, built-in data structures in Python, include the tuple. One unique thing about the tuple that is different from the list is the fact that once you declare it, it remains unchangeable. But it also allows duplicates and it's ordered. Then you have the set. So the unique thing about the set is that it's unordered. It's also unchangeable and unindexed, and it does not allow duplicates. So that's important to remember. Then you have the dictionary. So the dictionary is ordered. You can change the values once you've declared it, but the unique thing about the dictionary is that you cannot have duplicates in the dictionary. Now, these are called Python collections, and they're actually similar to arrays in other programming languages, but each one of them has their unique properties, as we have seen. Okay, so we're going to look at each one of them briefly after we are done with Python lists, but we're going to spend a bit more time on Python lists. So similarities between arrays and lists, important to know so that you know when to choose which one and when to avoid. So of course, for similarities, we've already talked about indexed, ordered, changeable, that is mutability, iterable, meaning to access the elements, we need to move from one element to another sequentially. Sliceable, meaning we can break down an array or a list at a particular point and be able to have two separate lists. The difference, main one, is arrays can only contain elements of the same data type, but for lists, you can have multiple data types. So we're going to see this in the practical in a few. Now, arrays also have a fixed size, so you cannot change it once your program is running on runtime. But lists can grow dynamically. So you see, now these differences are telling you when to use an array and when to use a list. So if you want to hold data of the same type only, go for an array. If you need a variable that can hold multiple collections of data, different data types, then you go for a list. Fixed size, again, if you want an array like that can grow dynamically, you go for a list. Now, arrays are also stronger in terms of doing numerical computations. So if you need to perform mathematical computation on numerical data, then you go for an array. So this is not very possible in lists, for example. So we're going to do one example, and you're going to see how that really works. So lists, they're just general purpose, but if you need to do serious mathematical computations, even the basic ones, by the way, you need to store that data in arrays. Arrays are also memory efficient because if it has a fixed size and you already know the number of items that you're going to store, then only the required memory space is going to be created. On the other hand, for a list, if for a list really, because it can grow dynamically, then once you declare, then it's going to declare some more spaces that are not going to be used. So arrays are more memory efficient compared to lists. Also, on memory efficiency, before you attempt this, you can just ignore the timer, or let me just go back. Okay, so also on memory efficiency, what did I want to say? Okay, so also memory efficiency, we know that different data types occupy different space size in memory. For example, an int, let's say 2 bytes, a long int, 4 bytes, etc., etc. So when you're declaring a list, you see, because it can store data of multiple types, it will definitely have a bigger space that might not be used. But for arrays, it will just have the exact, and it's easy to calculate what memory is needed for the array compared to lists. Okay, so you can give this a try. Feel free to pause if the timer is moving too fast for you. Okay, so let's move on. So just like arrays, you can traverse a list, you can sort items in a list, you can delete items from a list, you can search a list, and you can update items at a particular index of a list. So a list is also index based. Some methods for lists, the same methods that we looked at when we were looking at the array topic. If you haven't watched it yet, please watch the previous array topic video that is on this playlist. So these are the usual functions that you can use with a list. For example, append to add an element at the end of the list, pop to remove and return an element at the given index. Len, L-E-N, to return the number of elements in the list. So please go over that again. So let's give this a try again. Time to think. Go for it. Pause if the time is going too fast. Okay, so that particular function is used to remove an element from a list. So you pass it the element and not the index. So that was the trick there. Okay. List operations, the runtime complexities are very similar to arrays, by the way. So again, feel free to watch the arrays video in order to understand each of those time complexities. So in this particular video, we've been able to define what a list is, and we've said that a list is one of four built-in data structures in Python. It can hold multiple or a collection of items of different types. It's also index-based, just like an array, and it has similar properties to an array, apart from the fact that it can hold multiple items. We've also looked at the list operations and the list time complexities. So that is it for this particular video. Thank you for sticking to the end. So in the next video, we want to dive into implementing the list operations using Python on Visual Studio Code. So see you then. Bye-bye for now.